In today's lesson, we are going to look at using patterns to start learning about algebra. Now, this might be a review of what you've done in grade 8. It should be a review, but in case you just forgot or you don't quite remember, we're going to look at using patterns to, again, start learning about algebra. We're going to start with robot tables and multipliers. So, I have an input column and an output column, and the way this works is I'm going to give my robot a number, and it's going to generate a new number or an output. So let's say, for example, I input 3. I put that into my robot. It does a small calculation, and I get 21. Let's say I put in a new number. Let's say 5. The robot does a calculation, and we get 35. We put in another number. Let's say we put in 9. And we get 63. Put in a couple more numbers. Let's say 11 and let's say 1. Some final calculations by our robot, and we get 77 and 7 as our two outputs. So we need to think about what rule is the robot following, or what calculation is the robot doing to get from our input number to our output number. You can look for a pattern, look to see what kind of operation you could do to the input number that is the same for every single one. And if we look at it, or we think about it, we should see that to get from the input to the output, we're multiplying by 7. So for our rule, we could say the input number multiplied by 7 equals the output. We could say multiply by 7. And if you remember, you might be able to put this into a formula, something along the lines of y equals 7x. We're basically saying a number times 7 is going to equal another number. Now, the key thing that this rule uses or follows is what we call a multiplier. And a multiplier is a number that you multiply by, so kind of straightforward from the term itself. It changes with each input. By that I mean, or it changes the input. Or what the input increases by every sequential term, or every term, right? So if we go input a number in by 1, then to 2, then to 3, we're changing by the multiplier every time, or increasing by the multiplier every time. But the key thing is it's a number that you multiply by. So if we look at another table, let's say we look at, say, the numbers 2, 4, 7, 10, and 0. So we plug all those numbers in. Our robot goes through some calculations. We get 22, 44, 77, 110, and 0. We're going to do the same thing. We're going to look for what rule or calculation is our robot doing in order to get our output number from this input number. And again, if we think about it, look for that pattern between them. We should see, to get from one to the other, we multiply by 11. 2 times 11 is 22. 4 times 11 is 44. 7 times 11 is 77, and so on. So if I want to come up with my rule, again, I can put it in two ways. Input number multiplied by 11 equals the output. Or I could just say as a general formula, y equals 11x. So we're going to look at a couple more examples. So again, we're going to focus on looking at how do we go from the input to the output. Same thing in B. So the nice thing here is that we're just focusing on patterns that have a multiplier. So all we're focusing on is what number can I multiply to get the input to the output. A is nice because our robots have used the exact same pattern that we've looked at in the first one, which again was y equals 7x, which meant that we multiplied our input by 7 to get our output. So our input multiplied by 7 equals the output. Or y equals 7x. Again, different ways you can write it or describe it, but as long as you're understanding what we're doing to change the input to the output. For B, if we look at the numbers that we have, so we have 2 to 16, 4 to 32, we don't know what 6 turns into, but once we figure out the rule, hopefully we can go back and fill that out. 8 to 64, and then something that gives us 80. Again, we're looking for what numbers do we multiply the input by to get to the output. And it has to be the same multiplier or the same rule for all of our input numbers. So if we look at them and think about, well, what does 2 multiply to give me 16, or 4 to 32, and 8 to 64, if you go through, maybe you can tell it what it is right away, or maybe you guess and check. But we should get that we multiply by 8 to get our output. So our rule is the input multiplied by 8 equals the output. If you want to put it as a specific mathematical formula, you could say y equals 8x. Again, our multiplier is the 8 here. So going through, I can fill in the missing spots because I can do, I can do 6 times 8, which is the rule my robot's using, and get 42. Oh, not 42, sorry, 48. But how would I get this last one here? You may be able to look at it right away and figure it out. Well, I know what I have to multiply 8 by 8 to get to 80, right? Which would be 10. Or what you could do, if you're going in the reverse from output to input, what you can do, or what you're going to want to do, is do the opposite of our rule. Because we're going in the other direction, the opposite of multiply by 8 is divide by 8. So 80 divided by 8 gives us 10. So if we're finding out the output, we're just basically multiplying or following our rule. If we're trying to find an input number, we're going to reverse our rule or do the opposite, which is where we get the divide by 8 from. Moving on to C and D. Again, we're only given a couple of them. So we're given 2 to 18 and 8 to 72. We're given a bunch of other inputs, but we're not sure what that is. So we need to figure it out. So if we think about what our numbers are, what multiplies 2 by what gives us 18, and the same rule, 8 by what gives us 72. So thinking about it, thinking about our numbers, and we should recognize or find out whether we can tell by looking at it or tell by guessing and checking using our calculators, we would multiply by 9. So that means 9 times 9 gives me 81. 2 times 9 gives me 18. 3 times 9 gives me 27. 0 times 9 is 0. 8 times 9 is 72, which we already had. So again, our rule would be input multiplied by 9 equals output. You may already want to use a formula or be comfortable using a formula. So you could say y equals 9x. Again, if we want to label these, instead of writing it just input and output, we can write I and O. For D, it's going to be the same thing. I and O, input, output. Here we're only given one situation where we have an input and an output. So we need to think about, okay, what can we multiply 16 by to get to 32? Realistically, we could have multiple options here, but we want to stick to kind of the whole numbers that we're given. We're using whole numbers as our multiplier. So in this case, what whole number can I multiply 16 by to get to 32? That would be 2. So my rule here is going to be multiply by 2. So if I'm multiplying by 2 from input to output, I can figure out the third and the final one, because 8 times 2 is 16, and 32 times 2 is 64. Now, if I want to find the input, that means I need to work backwards. So if I'm going in the other direction, in reverse, I'm going to do the opposite of my rule. So I'm going to divide by 2. 2 divided by 2 is 1, and 8 divided by 2 is 4. So I can reverse my pattern or do the opposite of it to figure out what the input is, or basically the other column. So again, my rule was input multiplied by 2 equals output, or y equals 2x. As we continue along, we're still going to focus on the idea of just multipliers, but we're going to look at patterns rather than tables. So if I look at the following pattern, I see my first position, my second position, and my third position. If I wanted to kind of guess what the fourth position would be, I can look at what my pattern is, and I might recognize that I'm adding a row of 3 every single time. So my fourth position would just be 4 rows of 3. If we needed to, we could create a table similar to what we did in the last examples and put position number similar to our input number and number of tiles. We can go through, and I have position 1, 2, 3, and I do have 4 now because I figured out what the pattern was. And in terms of the number of tiles, I have 3, 6, 9, and 12. So I want to think about what is the rule. What rule is my pattern following? And there's different ways we can figure this out. I could say, well, I'm adding 3 every time to my pattern, or every position it's increasing by 3, which is true. But I want to somehow relate the position number to the number of tiles. Similar to how when we came up with the rule in our robot tables, we were looking at how does the input become the output. So in this case, how does the position number tell us the number of tiles? We can use this value here of plus 3 in our rule because we should recognize that our rule would be y equals 3x. Or our multiplier in this case is 3. It's what we're multiplying our input number by. If we wanted to, we could change this to say tiles equals position number times 3. And again, different ways you can write this, different letters you could use, but as long as you're multiplying the position number by 3, that would give you your rule. So how many tiles would be needed for the 100th position, or sorry, the 10th position? So we could continue our table or continue our pattern if we wanted to by drawing it out, or we could use the rule to save us that time. So I know the tiles is going to be 3 multiplied by the position number. So 3 times 10 is 30. So I know there are going to be 30 tiles in the 10th position. For the 100th position, I'm going to do the same thing. Right, I'll use the other formula. So tiles equals position number times 3. So the number of tiles is equal to 100 times 3, which is 300. Now, what if I already know how many tiles I have and I want to figure out what position would that build? Well, this is similar if we think of our table. This is similar if I know the first column, or the second column, sorry, but I'm missing the first one. And if we think back to our input-output tables or our robots, if we're going backwards, we would want to do the opposite of our rule, which in this case would be divide by 3. So 36 divided by 3 is 12. So that means our position number would be 12 with 36 tiles. Right. We'll look more later at how that would look mathematically, but essentially what's happening is we're kind of doing the opposite. Not 12, sorry. 36. We have 36 tiles. And that equals 12. Again, this we'll worry about later. This is more the mathematical process. But as long as you understand that you're just reversing the pattern to get your position or input number. All different terms for the same thing. Or different words for the same term, you could argue. In our next example, again, the same idea. So I know it might be a little bit redundant, but again, the practice can help just strengthen our understanding. So we're looking at our new pattern. If I want to predict what the fourth one would be, I want to see how they're changing every single position. And it looks like we're adding 2 every time. So we had 6 in the last one. So that means we should have 8 purple squares in the fourth one. If you weren't sure of what that pattern was, again, feel free to create a table. Instead of input-output, we'll use position and tiles. And we'll see that in position 1, 2, 3, and 4, we have 2, 4, 6, and 8 tiles. Right? We want to see how does the position become the number of tiles, or what the pattern is from going from our input to our output. And we should recognize that we're multiplying by 2. Another way we could see that is that if we look at our pattern, it's increasing by 2 tiles every time. So that's another way that we can figure out our multiplier. What does it increase by each time? And that's what I was kind of alluding to back when we talked about the multiplier. Because for our rule, you could say position number multiplied by 2 equals number of tiles. You could say y equals 2x, or you could say something, or changing the letters, you could say the number of tiles is equal to position number multiplied by 2. Again, all different ways to represent the rule. How many tiles would we need for the 9th position? Well, again, we can plug that into our rule or use our rule. So we can say 9 times 2 equals number of tiles. In this case, 18 equals the number of tiles. We could continue on the table or continue on the pattern if we couldn't quite figure out the rule, but to save time, that's where the rule is helpful. How many tiles do you need for the 100th position? So same idea as what we just did. Instead of using 9, we can take 100 multiplied by 2, which is our rule, will give us the number of tiles. So we get 200 equals t. The last question, if I have 42 tiles, which position can I build? So again, this goes back to what we were looking at before with our table and where we had an output but looking for our input. So position numbers, tiles. Here we're given the position of 42 and we're looking for, the tiles of 42, and we're looking for the position number. We know the rule to go from position to tiles is multiply by 2. And hopefully we recognize now that if I want to go the other way or the other direction, I'm going to do the opposite of this. So the opposite of multiply by 2 is divide by 2. So in this case, 42 divided by 2 is 21. So that means our position number is 21. I'm just going to write down mathematically what we're doing. So tiles equals position number times 2. 42 tiles equals a number multiplied by 2. To figure out what that number is, it would be 42 divided by 2. And we get 21 equals the position number. So again, different ways to represent what we're doing. We'll look at this formula later, but for right now, as long as you can use the table or just recognize that you reverse the pattern, that is good. Now we're going to get a little bit more complicated in our patterns because we're going to add a second term or a second characteristic or part of our rule. And that's what we're going to call a constant. So we're going to look at our tables first. So we're given a robot table again. So we're given some input numbers, let's say 0, 2, 5, 7, and 10. We plug them in, our robot does some calculations, and we're spitting out a number of 1, 5, 11, 15, and 21. So now we need to think about, okay, what is the rule? And if we look at this, there's no number that I can multiply 10 by to get to 21. Same with 7 to 15, 5 to 11, 2 to 5, and 0 to 1. So there's a little bit more to my rule now than just multiplying a single number. So this one might take a little bit more of more time to kind of figure out the rule. But when you go through, maybe you guess and check, maybe you recognize the pattern right away. What you should find is that to get from my input number to my output number, I need to multiply by 2 and add 1. 0 times 2 is 0, plus 1 is 1. 2 times 2 is 4, plus 1 is 5. 5 times 2 is 10, plus 1 is 11, and so on. So in this case, my rule is input multiplied by 2 plus 1 equals the output. Mathematically, if I want to write it as an equation, y equals 2x plus 1. So that is my rule that my robot's using to go from my input to the output. let's look at one more example. So again, let's use the same numbers, 0, 2, 5, 10, and 1. So we plug these numbers in. And our robot spits out 2, 8, 17, 32, and 5. So again, we're going to try to figure out, okay, what is our rule? Looking at these numbers, well, I can multiply 1 by 5 to get to 5, but if I multiply 10 by 5, I don't get 32. I can multiply 2 by 4 and get 8, but 5 times 4 is not 17. So my rule is not going to have just a multiplier. So I need to think about, or maybe use some trial and error, some guess and check to figure out what number or what is my rule to get from the input to the output. And again, with some trial and error, some working through it, we should find that I would have to multiply by 3 and add 2. 0 times 3 is 0, plus 2 is 2. 2 times 3 is 6, plus 2 is 8. 5 times 3 is 15, plus 2 is 17, and so on. So my rule is the input multiplied by 3 plus 2 equals the output, or you might say y equals 3x plus 2. So the rules that we're looking at now, these rules add what we call a constant. And a constant is a number that doesn't change. So in this case, it doesn't matter what our input is, the constant is always going to stay 2. The input will change our multiplier, right, because we're going to multiply it by that. But the constant doesn't change, right? You could think about it's added or subtracted in our rule. Two other terms that you're not going to see too often, but it does help if we see it or if we just recognize it. Direct variation is a rule with only a multiplier. And partial variation is a rule with a multiplier and a constant. So you might see these terms as a simple rule and a complex rule. So simple is direct variation. There's only a multiplier. Again, they're the easier ones. And then partial variation means there's a multiplier and a constant, so we would call that complex. So let's look at some more examples of that. Again, I'm not going to write input-output anymore. I'm just going to write I and O. So 1 to 6, 2 to 11, 3 to 16, 4 to 21, and 5 to 26. So we need to think about what is the rule. What can I multiply these numbers by to get from the input to the output? And generally speaking with the rules, these ones are going to include we have to multiply by something and we may have to add or subtract by something. In our case right now, it's just going to be adding. So what numbers can we multiply and then what numbers can we add to get from the input to the output? And if we think about it, we go through some trial and error, we should find that we have to multiply by 5 and add 1. 1 times 5 is 5, plus 1 is 6. 2 times 5 is 10, plus 1 is 11. 3 times 5 is 15, plus 1 is 16. And it works for the rest of them as well. So we could write input times 5 plus 2 equals output. If we wanted to shorten this, we could write I times 5 plus 2 equals O. Or you may be familiar with y equals 5x plus 2. The reason we've been using y and x is because this table might be similar to a table that we would graph a scatter plot with, right, or a table of values, in which case the first column would represent x and the second column would represent y. Right, we talked about before, when dealing with graphing, the first column always represents x or our horizontal axis, and the second column represents y or our vertical. So again, we want to figure out, how do I go from my input to my output, or from my x value to my y value? Again, same idea, just different terms. First thing you might want to do is check, can I multiply these numbers by a single value to get from the input to the output? Well, an easy one to look at is 10. I can multiply 10 by 8 to get to 80, but can I do that with 8? 8 times 8 is 64, which is not 66. So I can't multiply by 8. I need to have something else. So you take a second to think about it. You might find that the rule is you multiply by 7 and add 10. 2 times 7 is 14, plus 10 is 24. 4 times 7 is 28, plus 10 is 38, and so on for the rest of them. So you could find the pattern there. Now, the rule, again, we already have our rule up there. We could write it out the long way. I'm going to write it out just in words, just so we can at least understand what we're doing. You might say multiply by 7 and then add 10. Mathematically, if we want a formula, I would say it's the x value multiplied by 7. So I'm going to say 7x, because again, if I have a letter and a number side by side, I'm going to assume that the operation is multiplying. So 7x plus 10 equals y. Or I could put y equals 7x plus 10. It doesn't really matter where I place that y. Whether it's at the end or the front, it still means the same thing, but generally speaking, it would come at the front. Let's look at C. So here we have certain values in our input and we're missing some in our output and vice versa. So we have to look at our two values here, or at least the two pairs that we're given, to figure out, okay, what is my rule? Now, we do have two values, which is nice. And if we're looking at them, how do I go from 8 to 31 and from 7 to 28? So in this case, again, you may want to play around with some values. It may come to you right away. And looking at it, I believe the rule would have to be the input, or the x, multiplied by 4 sorry, not 8, multiplied by 3. So the input, or the x, multiplied by 3, and you add 7. So 3x plus 7 equals y, or again, you could say y equals 3x plus 7, or you could say multiply by 3 and add 7. Now, is there a nice way to figure out how that works? Well, if we look at these two values here, these are one after another. And if we think about, well, okay, if it's one after another in terms of our robot or in terms of a pattern, what does our output number change by? And here, we go up by 3. Where else do we see 3? Well, 3 is also our multiplier. So when we have sequential numbers, if we find what the outputs are, or we know what the second values are, the second column, if we figure out what they change by, we can figure out our multiplier. Right? 7 and 8. Oops, I guess I should put this backwards. From 7 to 8, that's one position apart, and I've increased by 3. That increase by 3 tells me my multiplier, because that's what I'm changing by every time. Now, to figure out the constant, you would have to do a little bit of math. If you know this is the multiplier, well, you can do 7 times 3, which is 21. Well, what do I have to add to 21 to get to 28? It has to be 7. Oop, not 8. You can test that with the other rule. 8 times 3 equals 20. Oop. We had 24. 24 plus 7 equals 31. So that does work. So that is our rule for this situation. And now we can use that rule to fill in our missing spots. So 2 times 3 is 6, plus 7 is 13. I'm going to go down here. 3 times 3 is 9, plus 7 is 16. And again, we see that same increase. From 2 to 3, an increase of 3. So it's still that multiplier. To figure out this missing value here, how do we go backwards? Well, if we know our rule going forwards is multiply by 3 and add 7, the same applies that we've done before. I'm going to reverse this. So I'm going to do the opposite. And I'm going to go opposite directly. So the last thing I did was to add 7. That's going to be the first thing I do. I'm going to subtract 7. Then instead of multiply by 3, I'm going to divide by 3. So I'm going to minus 7 and then divide by 3. So let's do that for 19. 19 minus 7 equals 12. Then 12 divided by 3 equals 4. So that's my missing x value there, or my missing input value. So again, same rules apply. We're going in reverse. We're going to do the opposite of our rule. So we have 2 other questions. So now 2 new tables. We're going to use our rule. Determine the value of y when x is 13. So this is just an easy one because we're going straight forward. We're going forwards with our pattern. We're using it as we know it. We can use our rule, y equals 3x plus 7. Or the output is equal to 3 times the input plus 7. Different ways to write this. I can say 3 times 13 plus 7. 3 times 13 plus 7 equals 46. So that means when my input is 13, my output is 46. For 2, I want to figure out the value of x, or my input, if the output, or y, is 25. So here I'm just going to go in reverse. I'm going to subtract 3 first. So 25 minus 3 is going to equal 22. Oh, not 3, sorry. My mistake. 25 minus 7 is what I'm going to do first. Equals 18. 18 divided by 3, which is the next step in reverse, equals 6. So therefore, y equals 6. Now, mathematically, and we'll get into this later, we would have y equals 3x plus 7. The output, or the y, is 25. Then we start reversing our pattern. 25 minus 7 is equal to 3 times the number. We get 12 equals 3 times the number. 12 divided by 3 equals that input value, or that missing number. Sorry, not 12, 18. Divided by 3, and we get 6 equals our input. So again, different ways to do it, but as long as you can focus on this method here, where you're just reversing the pattern. Don't worry too much about this second one that's more mathematically laid out, as long as you can understand that you're reversing the pattern. Moving on to D. So for D, we're only given 2 values. 0 gives us 20, and 4 gives us 36. Now we can't use that kind of rule that we used last time because we don't have numbers that are side by side or that are sequential. Once we fill out the chart, we will have our 3 and our 4. However, right now we don't have them. So we have to use a different tip or a different strategy. Right? We could, again, use trial and error, figure out what I multiply 0 by, and add something to get to 20, multiply 4 by something, and then add something to get to 36. We could look for a multiplier only, or a direct variation first. Is there a number that we can multiply 4 by to get to 36 and 0 by to get to 20? There's not. So we need to think of something else. One thing you might be able to recognize is this first value here, 0. And why is that important? Well, 0 multiplied by anything is going to equal 0. It doesn't matter what I multiply it by, it's always going to be 0. So that's helpful, because if I think of my pattern, I need to at least add 20, because 0 multiplied by something is 0. So I've taken care of my multiplier. The only way I can get 20 is if I add it. So I need to add 20. So I know from my rule, I'm going to add 20 at the end. I don't know what my output's going to be, and I know then I need to figure out what's my multiplier. What am I multiplying by first? And using that value, or using that input, that constant of 20, I can use that to help me down here with the other one that I'm given, because I know that when I go in reverse, I have to subtract 20 first, and that might help me find my multiplier. Because if I do 36 minus 20, I get 16. So that means 4 times something gives me 16, or 16 divided by something gives me 4. Just the 2 different directions, but I should find that 16 divided by 4 gives me 4. So that means that my multiplier, or the number that I have to multiply by, is going to be 4. 4 times 4 is 16, plus 20 is 36. And then going in reverse, 36 minus 20 is 16. 16 divided by 4 gives me 4. So that does work. So that means then that my multiplier is 4. I'm going to put the x there to show that I'm multiplying that multiplier by my input value, or my x, by putting it as 4x. Now I can go through and fill out the rest of the table. 3 times 4 is 12, plus 20 is 32. 7 times 4 is 28, plus 20 is 48. 9 times 4 is 36, plus 20 is 56. So that's what my table is going to look like. Now we can see that kind of relationship between the sequential numbers. From 3 to 4, we can see that increase of 4, which would be our multiplier. And we can kind of see our constant again coming up in this plus 20 part. So using our rule now, we can answer these two questions. So what is the value of y when x is 11? Or in other words, what is the output when the input is 11? If you want to use the table and use your rule, you can. If you want to use the formula, y equals 4 times 11 plus 20, you can. Either way, you're going to come out to the same answer, which is 64. 4 times 11 is 44, plus 20 is 64. For number 2, here, what determine the value of x when y is 40, or basically determine the input when the output is 40. Again, we're only going to focus primarily on using the pattern in reverse. So in reverse, 40 minus 20, right? That's the first thing we're going to do in our pattern. 40 minus 20 is 20. Then the next thing we're going to do is divide by 4. Again, the opposite of multiply by 4. And we get 5. So therefore, our input, or x, is equal to 5. Going to look at one other question, or another question. Again, same idea. Again, getting us used to finding the rules, especially when there's a multiplier and a constant, because those are going to be a little bit more tricky. But now we know some tips that we can kind of use to help us find it, right? Because we know we can either look for the multiplier or the constant depending on what input values we're given. So we're given 1 and 108, 10 and 180, and 2 and 16. So the nice thing here is, again, we've seen this before, I have sequential numbers. From 1 to 2, I have, so you could think of position 1 to position 2. What does it increase by? Well, looking at those values, we can see that it increases by 8. So that increase of 8 from one position to the next, or from one step to another, that tells me what my multiplier is. I know it's going to now be y equals 8x plus something will be my rule. So because I know what I'm going to multiply by, I can do 1 times 8, see that I get 8, and figure, okay, what do I have to add? Well, the only way to get to 108 from 8 is by doing 8 plus 100. Does that work with the other ones that I'm given? Well, 10 times 8 equals 80. 80 plus 100 equals 180. That does work. And we could do the same thing with 2 and see that that also works as well. So that means my constant, or the number that I'm adding, is going to be 100. So again, because we saw the increase or the change from one position to the next in sequential order, so from 1 to 2, we saw that we went up by 8. We found our multiplier, and we used that to help us figure out what our constant was. So now if I go through, I can fill out the rest of the table, because I can do 4 times 8, which is 32, plus 100, 132. 6 times 8 is 48, plus 100 is 148. Again, using that rule, I can go through and figure out the different questions here. determine the value of y, or the output, we could say, if you're comfortable using that, when the input is 9. So y equals 8 times 9 plus 100. Or again, you could just do 8 times 9 plus the 100. Don't worry too much about the equations right now. And you should get 172 is your y value, or your output. To determine the value of x, or your input, when the y is the output, or when the output, is 188, again, now we're going to go in reverse. So we know going one way, again, was multiply by 8 and add 100. Going in reverse, we're going to do the exact opposite. Minus 100, and then divide by 8. So 188 minus 100 equals 88. 88 divided by 8, the next step, equals 11. So therefore, x, or my input, equals 11. So again, just using, again, the idea of looking at sequential numbers or steps to find what the change is. That change, or that plus 8, is going to tell me what my multiplier is. And then from there, I can figure out what my constant is and then use my rule to find missing values. We're going to look at one last one. Here it's going to be a little bit more complicated. This one's more complex because we're not given either an input of 0 or two sequential inputs, so two inputs that follow one another. Right? We don't have 1 and 2, or 3 and 4, or 2 and 3. Right? We're missing, or we're doing every other one. So there's different ways we can figure this out. We can still use the idea of kind of patterning or looking at what we're increasing by to help us figure that out. Right? Because if I go from 2 to 4, or from 4 to 2, and I see that my values increase by 1, that can help me out. And it would help us out if maybe we visualize it. So let's visualize it. Let's say we have position 2, 3, and 4. So at position 2, let's say we just have 4 tiles, right? Or 4 numbers, or whatever the case may be, right? We can use interchangeables, and we use different visuals. And we know at 4 we have 1, 2, 3, 4, 5. So if I'm looking at my patterning here, if I go from 2 to 4, I increase by 1. But in order to have 3, or let's say I'm going from 2 to 3 and then 3 to 4, these two steps, or these two increases, need to be equal. The pattern doesn't change or increase by different amounts every time. So we need to figure out, well, if a jump from 2 to 4 is 1, what would a jump from 1 to 2, or from 2 to 3 be? And then 3 by 4. Basically, we're taking this value here and dividing it into 2 jumps, or 2 different increases. So 1 divided by 2 is a half, or 0.5. So if I was to jump from 2 to 3, I would increase by a half. From 3 to 4, I would increase by another half, which gives me that total of 1. Now, if I kind of just remove this plus 1 just for a second, I'm increasing by a half every single time. Every increase, or every position that I change, I increase by a half. That's the same thing as our multiplier. Right, so this here is our multiplier. Right, same as when we looked at the patterns before. Here we had to break up a larger step into 2 smaller steps to help us figure out that multiplier. So again, I know my multiplier is 1/2. Using that, I can figure out what my constant is, because I can do 2 times 1/2 and get 1, Well, 1 plus what gives me 4? The only option is 3. If we look at 6, does this pattern still work? Well, 6 times 1/2 equals 3. 3 plus what gives me 6? The only option is 3. So it seems like our constant is going to be 3. My mistake, 3. So that means our rule from input to output from x to y is multiply by 1/2, then add 3. Now that we know what that rule is, we can go through and answer these other questions for these other numbers. Right? What is the value of y, or what is the output when the input is 20? So we can use our rule as is, so 1/2 times our input, or x, which is 20, plus 3. We get 10 plus 3, which is 13. So our output is going to be 13. For 2, determine the value of x, or our input, when the y value, or the output, is 20. So here we're just going in reverse. So let me just move this just up out of the way for a bit, or we'll move it off to the side here. We'll put in the reverse of our pattern. So the opposite, we're going to divide by, not divide. Instead of adding by 3, we're going to subtract 3. And then we're going to divide by 1/2. So let's start off by going in reverse. We start at 20. 20 minus 3 equals 17. And then we have 17 divided by 1/2. Which gives us 34. So that means our input, or our x, is 34. And if we wanted to check this, then we could say, okay, well, let's go the other way. Let's use our actual rule for a position number 34. 34 times 1/2 is 17, plus 3 is 20. So that gives us the value that we're looking for. So once you have the rule, it's a nice way to help you check some of your answers. Let's look at a couple of examples just with the tiles, just kind of help us, again, maybe to visualize some of our patterning here. So position number 1, 2, and 3. We'll put 4 down to predict. So let's look at our pattern. So how many red squares or tiles do we have? Well, if we count them up, we have 5. How many teal squares? We have 4. Let's continue to look at the next pattern. How many red squares? We have 10. Teal squares, 4 again. Position number 3. Well, teal squares seems to be easy. It's 4 always. And for the red squares, we have 15. So what are our total number of tiles? Well, if we go through, 5 plus 4 is 9, 10 plus 4 is 14, 15 plus 4 is 19. What would the next position be, do you think? A number 4. Well, if we're increasing by 5 every time, it seems, or a row of 5, or a column of 5, we'd have 1, 2, 3, 4 rows of 5, and our teal ones wouldn't change. They haven't changed at all, so they're not going to change if I add another row. So I'm still going to be stuck with 4 teal, and now I'm going to have 20 red squares. So in this case, I have 24 total tiles. If we wanted to guess position number 5, Well, I'm not going to go through and draw it, but I do start to see the pattern here. The tiles don't change, so we're at 4 teal tiles. And for the red tiles, they increase by 5 every time. So I'm at 25. And in total, I have 29 tiles. So I want to think about what is the rule. And visually now, it's a little bit easier because I can see what is changing every time and what is staying constant. So again, my multiplier is what's changing every time. So my multiplier is going to be represented by the red tiles, and my constant is going to be represented by the tiles that aren't changing, which are the teal tiles. So in my rule, it would be y, or position number, equals my multiplier, which in this case, because I'm increasing by 5 every time, or my multiplier, or these red tiles are changing by 5 every time, it's going to be 5 multiplied by the position number, or x. Let me just use a different color here. Plus the constant, which is 4. So those are different ways you can figure out what your two rules are. The constant, visually, it's what's staying the same. And again, we've also talked about when we see sequential numbers or steps, what they're changing by every time tells us the multiplier, and we can visually see that. So our rule, we've already figured that out. Y equals 5x plus 4, or basically multiply by 5 and add 4. So for our 10th position, 10 times 5 is 50. 50 plus 4 equals 54. So that is our answer. So 54 tiles for the 10th position. For the 100th position, it's the same thing. 100 times 5 equals 500, and then we're going to add 4. So 500 plus 4 equals 504. So at position number 100, you need 504 tiles. What part of the rule is represented by the red tiles? Well, red tiles are the multiplier. And how do we know that? Well, they're changing. Changing each position. What tiles are represented by the blue? So blue tiles are the constant. And they stay the same. So given a visual pattern, it's really easy to see what the multiplier is and what the constant is, because you can visually see what's staying the same and what's not. Let's look at one more example. So here again we have our position number 1, 2, 3, 4, and we don't have 4 and we don't have 5, but we'll draw them, or at least draw 4 and then predict what 5 will be. So looking at our tiles, we can see that these teal ones are not changing. The only thing that's changing are the purple ones on the inside. And it looks like we're adding a row of 2 every single time. So that means in our 4th row, we're going to have 4 rows of 2. We're going to have our teal tiles on the outside. Here, we're not breaking it up step by step, so let's just count the number of tiles in total. So we have 1, 2, 3, 4, 5, 6. 6 tiles in total for number 1. Number 2, 1, 2, 3, 4, 5, 6, 7, 8. 8 tiles in total. 10 tiles, 12 tiles. So you could make the prediction of what position number 5 is going to have, right? Because you can see what we're changing by every single time. We're going up by 2, up by 2, up by 2. So you could assume that if we go up by 2 again, we would get to 14. If you're not quite sure, you could also draw it out and check as well, but it is 14. Now we want to think about what is the rule. Well, again, here, it's really easy to see because there's two things. One, we can see what we're increasing by every single time. One in the tiles. Every increase for every position change, we're increasing by 2. We can visually see that we're doing that. And we hopefully know by now that that represents the multiplier. So we can see that from the table, and we can see that from our pattern. So we know right now at least that we have our position number, or that the number of tiles y is equal to our position number x multiplied by the multiplier, which is 2, and now we need to figure out the constant. So again, the constant we can figure out in one of two ways. Visually, we can see the constant. Those 4 squares represent the constant. Which in this case is 4. So adding 4. We could also use the multiplier and the position number and see what the difference is. Well, 1 times what? Or 1 times 2 is 2, so 2 plus what equals 6? The only option there is 4. And you can test that with the other options. Do 2 times 2, which is 4, plus 4 is 8. So it does work for the second one. And you could try it out for the third and the fourth one and so on. Which tiles represent the constant? Well, the blue ones. And which ones represent the multiplicative part, or basically the multiplier? That would be the purple ones, or the purple tiles. So again, visually, we now have a way to figure out the number or the different parts of a complex pattern or complex rule. Right? Visually, we can see what the multiplier is and what the constant is, and hopefully by seeing that visually, we can also see or make the connection to the table as well. Right? So then it might help us when we're dealing with the, say, just a table rather than a visual and a table, or just the visual. So again, it may be review, but make sure that you do kind of review these concepts and make sure you're comfortable identifying the pattern, whether it's a complex one or a simple one. We'll jump ahead right into our summary just to kind of go over kind of the rules or tips and strategies. So how to determine a rule from a table of values? Well, first, see if it's multiplier only. Right? Look to see, is it just as easy as multiplying a single value or the input by a single value? So in this case, if we look, 2 times what gives me 12? 5 times what gives me 30? Is it the same for every single input value? In this case, it is. We're multiplying by 6, and that's it. So that means my rule is y equals 6x, and this 6 represents the multiplier. If multiplying doesn't work, then it's a composite or a complex rule, which means it has 2 parts, a multiplication part and a constant part. So here, it's not as easy as just multiplying one value or multiplying it only, right? We can see that 0 to 3 is different from, say, 2 to 11. 2 2 times nothing gives me 11 in terms of a whole number. I can't multiply 5 by anything to get to 23, and so on. Right? So when we have two parts, there are two kind of strategies that we can use. One, it's helpful to have two consecutive input values, right? Or position numbers, 1 and 2, 2 and 3, 3 and 4, and so on. Why is that helpful? Because the difference in output values of consecutive numbers or inputs is the multiplier. Actually, let me just keep kind of a color coordination there. So the difference in output values of consecutive inputs is the multiplier. So that's what we were talking about before when you had one number that followed another, or if you're looking at a visual pattern. And the other part that might help, how might knowing the output value for an input of 0 be helpful in determining the rule? So we talked before that the output for an input of 0 is the constant. So if we know what the output is for an input value of 0, then that is going to tell us the constant. So looking here, we can see our constant. So in this case, I know so far that it's going to be y equals something x plus 3. And now you could kind of work backwards, right? So just an example, 11 minus 3 equals 8. And then I could figure out, okay, 8 divided by what equals 2. Or I could figure out, okay, 2 times what equals 8. In this case, it would be 4. 2 times 4 is 8. 8 divided by 4 is 2. Let's see if it works for, say, 9. 39 minus 3 equals 36. 36 divided by what equals 9? Or 9 times what equals 36? In this case, it is 4 again. So that helps us figure out the multiplier, which in this case would be 4. So there's a little bit more work when depending on what you're given. But again, as long as you can figure out either the constant or the multiplier, you should be able to then figure out the other value, or at least try to problem solve your way to the other value. So again, hopefully this is a bit of review. And if not, again, please make sure you're practicing or asking questions just to make sure that you're strengthening your understanding in going from patterns to algebra.